Coming up next, Jupiter, the fifth sun. I decide who lives and who doesn't. Without me, you are all dead. Ever think the only reason you're alive to watch this might actually be Jupiter? Not metaphorically, literally. 4.6 billion years ago, when the solar system had just formed, Jupiter was a thug. It was already huge, with terrifying gravity, rampaging through the solar system straight toward the sun. Everywhere it passed, rocky embryos that were slowly building mass to become planets were ripped apart, scattered, and swept away. Mars was wrecked right then. Mars could have grown into a planet bigger than Earth, with enough mass to hold a thick atmosphere and liquid oceans. But when Jupiter passed by, it stole about 90% of Mars's original material, freezing it forever as a dried-out red desert. If Jupiter had kept charging inward, Earth's fate was two words: gone. Either its gravity would capture us as a moon or fling us into deep space, drifting for billions of years in the dark. So why are we still here? Because Saturn saved us. Saturn formed along Jupiter's inward path, and its gravity created a tug of war with Jupiter. The two giant planets pulled on each other, stopping Jupiter's depth charge cold and kicking it back out to the outer solar system. With that one kick, Earth survived. But the story wasn't over. As Jupiter was thrown back, its gravity hurled huge amounts of ice from the edge of the solar system inward. Those ice chunks slumped into an Earth that still had no oceans. Scientists have measured that over 60% of the water molecules in today's oceans carry isotope signatures from icy bodies in the outer solar system. So every sip of water you drink probably contains some material Jupiter threw in from the solar system's edge during that chaos. The old butcher, by accident, delivered the water that made all life possible. After being kicked back outward, Jupiter settled into its current position and began doing something it probably never knew it was doing, serving as Earth's bodyguard. The outer solar system is full of comets and asteroids, many on paths aimed inward, straight at us. Once they get near Jupiter, there's usually one ending. They get scooped up and swallowed, or its gravity bends their path and throws them out of the solar system. In 1994, shoemaker Levy 9 died exactly that way. Jupiter tore the comet into 21 pieces and they slammed in one by one. The biggest impact equals 600,000 Hiroshima bombs going off at once, leaving a scar wider than Earth. But after studying it, scientists found it wasn't that simple. Jupiter blocks some objects, yes, but its gravity also stirs up the asteroid belt, throwing rocks that were quietly minding their own business onto a path into the inner solar system toward Earth. One estimate says that of the asteroids that have hit Earth, nearly 70% were actually sent our way by Jupiter's gravitational disturbance. The force behind the dinosaur killer may well have been Jupiter. So what does Jupiter do for Earth? It blocks knives for you and throws knives at you. So is it a bodyguard or a threat? Scientists are still arguing. Fine, that's the bodyguard part. Now let's talk about how absurd this thing itself is. Put the other 7 planets in the solar system on one side of a scale and Jupiter on the other, and Jupiter drops straight down. Its mass is more than twice all the other planets combined. Its volume could hold over 1,300 Earths. If Earth were shrunk to a glass marble, Jupiter would be a giant inflatable ball you couldn't even lift. But Jupiter almost wasn't a planet at all. If it had gathered about 80 times more mass, its core temperature could have crossed the ignition point for hydrogen fusion. It would have become a star. Then the solar system would have had 2 suns, with Earth trapped between a binary star's gravity, either thrown into chaos or baked into lava. It didn't make it. It came up just short, stuck outside the threshold of becoming a star, but it never fully cooled. Even now, it radiates more heat than it receives from the sun. After 4.6 billion years, that leftover warmth from the failed ignition still hasn't escaped. It's still leaking out. And that huge red eye on Jupiter's surface, you've definitely seen it. The Great Red Spot. A storm that's lasted at least 190 years. Its diameter is about Earth's. Winds top 400 kilometers an hour, and it reaches 320 kilometers deep, 30 times deeper than Earth's deepest ocean. When humans first observed it in the 19th century, it was big enough to fit 3 Earths side by side, but now it's shrinking, already down by nearly half. In 2014, Hubble stared at it for a full 90 days. The footage revealed something strange. It was trembling, sometimes flattening, sometimes stretching, like something struggling. And each time it shrank, its vertical height actually increased, like a pillar growing upward. Current models suggest the Great Red Spot survives by feeding on smaller storms around it. Cut off its food and it dies. Estimates say that without those little storms, it couldn't last 90 years. A 350-year-old monster, staying alive by eating storms. And then there's Jupiter's North Pole, a place scientists still can't explain. When Juno flew over the North Pole, its photos showed 6 to 8 cyclones, each wider than Earth, arranged around a central point in a perfect geometric formation, circling and holding that pattern for years. They don't drift apart and they don't merge. No other planet in the solar system has anything like it. No current theory can explain why it doesn't fall apart. It just keeps turning, like some kind of order we can't understand. Juno reached Jupiter in 2016. It traveled 1.7 billion kilometers and took 5 years to get there. It's now orbited Jupiter more than 70 times. It wears a 180 kilogram titanium radiation shield. Because Jupiter's radiation is 20,000 times Earth's, anything unprotected that gets close is blasted through from the inside out. Even with that armor, every close pass around Jupiter gives Juno as much radiation as 1 million X-rays, and the gravity data is sent back overturn decades of scientific assumptions. Jupiter doesn't have a clear solid core at all. Inside, metallic hydrogen and solid material are mixed into a blurry state with no boundary. No clear boundary at all. It's like a pot of something boiled completely to mush. No one knows how it formed. It's still a mystery. Finally, Europa, Jupiter's second moon. The whole world is sealed under an ice shell tens of kilometers thick. Beneath it is a liquid ocean over 100 kilometers deep, holding more water than all of Earth's oceans combined. In the cracks, we found organic molecules and signs of hydrothermal activity. On Earth, the earliest life likely crawled out of deep-sea hydrothermal vents. Europa's ice is also streaked with huge, mysterious red lines. Some scientists think they could be organic material brought up by deep ocean water. Around 2030, NASA's Europa Clipper and ESA's JUICE probe will both arrive there. For the first time in human history, we're seriously going to search a specific address for alien life, right beside Jupiter, right beside the bright point you can see with your naked eye tonight. So, what has Jupiter done over 4.6 billion years? First, it almost destroyed Earth itself. Then it delivered the water for our oceans. Then, out on the edge, it shielded Earth from countless deadly rocks. Then, it used gravity to squeeze one of its own moons into the place in the solar system most likely to hide life. It didn't think, it didn't plan, it just sat there with that absurd mass rewriting everything around it.